Hello viewers, welcome again to this segment. In this segment, we shall discuss 2x2 linear systems. What do I mean by 2x2 linear systems? It means two variables in two equations. We shall solve two variables in two equations using the substitution method. Now, like I said earlier, 2x2 linear systems means a system of linear equations, or you can say a system of two variables in two equations. They mean the same thing. Substitution. What do we mean by substitution? Comes from substitute. Substitute. Let's say you go to a restaurant and they have French fries and they also have a salad, right? And you tell them, okay, you want to substitute French fries for salad. You want to substitute French fries for salad. That means rather than taking salad, you want the French fries. If you want to substitute salad for French fries, that means rather than taking French fries, you take salad. So substitution means instead of taking this, you now want to take this. I want you to note this. Substitution is different from supplement. Supplement means you take both of them, like act as supplement. Substitute and supplement. Substitute means rather than taking this, you take this. You substitute this for this. But for supplement, you supplement this with this. Like if you want to supplement French fries with salad, that means you take the French fries and you also supplement it with salad. That means taking both of them. But substitute or substitution means you just take one rather than the other. In solving linear systems using the substitution method, there are two equations. There are two variables. The two variables are x and y. The two equations, we call this equation 1 and this is equation 2. I'm using ellipsis to write it and just parentheses. Equation 1 and equation 2. So anytime you see me write it this way, what I mean is this is equation 1 and this is equation 2. Now, where do you start from? You look at equation 1 and equation 2. In equation 2, you see that y is already isolated. Y is on its own. You want to start with an equation whereby y is already on its own, so that you can substitute 2x for y. You start with an equation, you now substitute something for the variable in that equation, and you now substitute it into the other equation. In this method, we try to use every equation at least one time. So, we don't want to use equation 1, we want to use equation 2 because it makes it easier for us since y is already isolated, y is equal to 2x. So we now say from equation 2, we have that y is equal to 2x. And then what we can do is we now write substitute. I'll just use this small form. This is substitute. Y equal to 2x into equation 1. Now, I've used equation 1. I will now have to use it in, I've used equation 2. I've used equation 2. I will now have to use it into equation 1. Or you can write it this way. Substitute equation 2 into equation 1. You can write it this way because you want to substitute this into equation 1. Or you can also say substitute 2x for y in equation 1. Some people prefer going with this. Substitute 2x for y in equation 1. And that is what I would kind of prefer to say. So because this means that wherever you see y, you put 2x. Just like the salad, substitute French fries for salad. That means instead of having salad, you take the French fries. So this means that we go to equation 1, and wherever we see y, we put the 2x. So we now have 5x plus y is 28. This is equation 1. This is equation 1. So we now put it like this: 5x plus 2x equal to 28. As you can see, rather than putting y, we now put 2x. So 5x plus 2x will give us 7x equal to 28. And of course, you divide both sides by 7, x will be 4. I would like you to review your the videos on equations so that we wouldn't waste time on this. Before you continue with this video, view the video segment on equations. So now the next thing we do is that we want to check our work, because we want to make sure that this solution is the same for both equation 1 and equation 2. But before we actually check, we have found x to be equal to 4. Now let's go ahead and find y. So what we can do here is we write substitute 4 for x in equation 2. We can now write substitute 4 for x in equation 2. Or you can say substitute x equal to 4 in equation 2. You can actually do it in any of the equations. But since you have substituted in equation 1, you can now substitute in equation 2. So from equation 2, we have that y is equal to 2x. So y will be equal to 2 times 4. And y will be equal to 8. So our x is equal to 4 and our y is equal to 8. The next thing we do is to check our work. Like I always do for equations, you need to check your work to see that you're correct. In this case, you have to check for both variables and for both equations. The equations must be correct for both variables. If one equation is correct and the other one is wrong, the whole answer is wrong. The whole answer is incorrect. So we start with equation 1, of course. We have 5x plus y equal to 28. Our left hand side and our right hand side, as usual, just like we checked. This is 5x plus y. This is 28. And in this case, our x is 4 and our y is 8. So this means 5 times 4 plus 8. And this is 20 plus 8, which is 28. So our left hand side is equal to our right hand side. Now we also do that for equation 2. Y equal to 2x. Here our left hand side is y. Our right hand side is 2x. So here our y is 8. And here our y is 2 times 4, which is 8. So we have 8 here, we have 8 here. And then problem number 1 is completed. That brings us to the completion of problem number 1. So let's go to problem number 2. Okay, this is question 2, equation 1 and equation 2. If you look at the two equations, as usual, we see that in the second equation, y is already isolated. So we don't need to do work in isolating a variable. Actually, you first of all do some work to isolate a variable, but in this case, we don't need to do that kind of work. It's already there for us. So all we need to do is we now say substitute 3x minus 1 4y in equation 1. Or you can say substitute equation 2 into equation 1. So what we have to do now is negative x minus 9 into 3x minus 1 equal to negative 19. This gives you distributive property, negative x, negative 27x plus 9 equal to negative 19. And that gives you, of course, as usual, like variables. You can work on them, like variables. So this is negative 28x equal to negative 19 minus 9. Negative 28x equal to negative 28. And your x will be equal to 1. Your x is equal to 1. You can actually call this equation 3. You can do that. You can actually call this equation 3. And then you can now say substitute equation 3 into equation 2. You can do that. So that means that y will be equal to 3x minus 1. Y will be equal to 3 times 1 minus 1. Y is 3 minus 1 and y is 2. Okay. Then the next thing we do is to check our work. For the check, we now have negative x minus 9y equal to negative 19. Left hand side, right hand side. And of course our x is 1, our y is 2. So left hand side here is negative x minus 9y. Right hand side here is negative 19. So this is negative 1 minus 9 times 2. Negative 1 minus 18, negative 19. It is correct for the first equation. We check for the second equation as well. Y is equal to 3x minus 1. Left hand side, right hand side. Here is y. Here is 3x minus 1. Y is 2. Here is 3 times 1 minus 1. 2 minus 3 minus 1, which gives you 2. 2 and 2. That brings us to the end of question 2. Alright, in this brings us to number 3. In this third problem, we see that none of the variables are isolated. None of the variables are isolated. So we have to find how we can isolate one variable. If you look at equation 1, we see that coefficient of x here is 5, coefficient of y here is 4. We look at equation 2. Coefficient of x is negative 1, coefficient of y is 1. When you have a situation when the two equations, you don't have any of the variables isolated, like you saw in the previous two problems, you try to find an equation whereby the coefficient of a variable is 1. It's good to start working from that equation. It's really good for you to start working from there. Because if you look at this now, if you start from 1, because the coefficients are 5 and 4, and this is negative 33, you run into fractions, which I know some of you don't like fractions. So let's start from equation 2, since the coefficient is 1, and we try to do the one in which the coefficient is 1, not negative 1. So negative x plus y is 12. So we now have that y is equal to 12 plus x. We call this equation 3. Equation 3. And then we can now say substitute 12 plus x for y in equation 1. Right? So this now gives us 5x plus 4 into 12 plus x now. This is now in parentheses because it's now 2 times 12 plus x equal to negative 33. And that gives us 5x plus 4 times 12 plus 4 times x equal to negative 33. 5x plus 48 plus 4x equal to negative 33. We collect like terms, right? 5x plus 4x equal to negative 33 minus 48. So that gives us that 9x will be equal to negative 81. And that tells us that x will be negative 9. So we found x. We can now say substitute x equal to negative 9 into equation 3, since it's easier for us that way. So y would be 12 plus x. Y is 12 plus negative 9. Y is 12 minus 9. Y is 3. So our x is equal to negative 9. And our y is equal to 3. As usual, we check. We have 5x plus y equal to negative 33. Left hand side, right hand side. Here is 5x plus 4y, and here is negative 33. And then our x, 5 times x is negative 9 plus 4 times 3, negative 45 plus 12, which is negative 33. And then the second equation, negative x plus y equal to 12. Left hand side is negative x plus y. Right hand side is 12. Here our x is negative 9 plus y is 3. So this is 9 plus 3, and that is 12. Two negatives make a positive. Negative 1 times negative 9 gives you 9. That brings us to the end of question 3. Now let's move to question 4. Alright, in question 4, we still have the two equations, and of course, no one of them is isolated. But in this case, the coefficient of y is negative 1. Here the coefficient of x is negative 1. So we can actually use any of them. We can actually use any of the equations. We can. Let's start with probably equation 1. I think we've been using equation 2. From equation 1, 3x minus y is negative 7. So y will be equal to... Now, you can write this way. So 3x plus 7 is equal to y. Negative 7 comes over here. Negative y moves over there. Make sure you view the video segment on equation so that you understand what I just did. So rearrange. If you rearrange now, we now see that y will be equal to 3x plus 7. And call this equation 3. So as usual, substitute equation 3 into, we've used equation 1, so let's substitute it into equation 2. So this means that 3 into 3x plus 7 minus x equal to 13. When you distribute this gives you 9x plus 21. Go ahead, make sure you also view the video segment on distributive property. Minus x equal to 13. So this is 9x minus x equal to 13 minus 21. If you collect like terms, so this is 8x equal to 13 minus 21 gives you negative 8. Right? So x will be what? Negative 1. And then you can also find your y now. You now substitute x equal to negative 1 into equation 3. So y will be 3x plus 7. Y will be 3 times negative 1 plus 7. Y will be negative 3 plus 7. And y will be 4. Alright. The next thing we do is to check our work. In checking our work, we write the main equation, 3x minus y, the first one. Left hand side, right hand side. Left hand side is 3x minus y, right hand side is negative 7. So we plug it in here. We plug in 3, negative 1, minus 4. Negative 3 minus 4, negative 7. Negative 7 on the left hand, negative 7 on the right hand. We are good. We also check for equation 2, 3y minus x equal to 13. Left hand side is 3y minus x. Right hand side is 13. Here we now have 3 times 4 minus negative 1, minus 1. So this is now 12 plus 1, and that is 13. Negative is a positive. 13 on the left hand, 13 on the right hand. We are good. It works for equation 2. That brings us to the completion of question 4. Okay, viewers, we are now in question 5. Now, this is equation 1 and this is equation 2. If you look at these two equations, you find out that, okay, none of the variables is isolated in any of the equations. So, then the second thing, none of the variables have a coefficient of 1. Like the former two exercises we did, none of them have a coefficient of 1 or coefficient of negative 1. So that brings us to another situation what do we have to do now in this case? All right, we look for the equation that has multiples of the same number. Like if you look at equation 1, you have -2, you have 6, you have 18. They are all multiples of 2. If you look at equation 2, you have a prime number there, 5, as a coefficient. So it will be easier for us to start with equation 1 in this case, so that we just have to divide it by the same, by -2, and we can isolate x. You try to find a way whereby you can isolate a variable. Okay, you start with an equation, you isolate a variable in that equation, you substitute for that variable in another equation. And that is the way it goes, right? You find an equation that will be easier for you to isolate a variable. And once you isolate a variable in that equation, you now substitute for that variable in another equation. So, and the process goes that way. So here we now say from equation 1, -2x is equal to 6y plus 18. So let's say we divide both sides by -2. We want to find x. We want to isolate x, right? Divide both sides by -2. So we have -2x divided by -2 equal to 6y plus 18 divided by -2. So x is equal to 6y plus 18 over -2. Now, this is now the same thing as saying that x is equal to 6y over -2 plus 18 over -2. And your x will be equal to -3y plus -9. And x will be equal to -3y minus 9. Call this equation 3. Some of you might be confused about this. If you are confused about this, the way I used, then try it this way. Divide all sides. Divide all terms. Here is divide both sides. Here, divide all terms by -2. So in this case, we have -2x over -2 equal to 6y over -2 plus 18 over -2. You can do it either of these ways. And this gives you, this crosses out, x will be -3y plus -9. X will be -3y minus 9. Equation 3. So any of the ways you want to do it, that's fine. So we found x. So the next thing, call this equation 3, right? The next thing is to do what? You now substitute. Substitute equation 3 into equation what? Now we've used 1. So let's use 2. Substitute equation 3 into equation 2. And from there, we now, what it means is anytime we see x, we just put -3y minus 9. So that brings us to -32 equal to 5y minus 4x. So -32 equal to 5 into -3y minus 9. Then minus 4. I'm sorry. This will give you -32 equal to 5y minus 4 into -3y minus 9. Right? Whenever you see x, you put -3y minus 9. So this gives you -32 equal to 5y. If you watch the video on distributive property, you will understand it better. This is -4 times -3y minus, bring down this minus, -4 times 9. So this is -32 equal to 5y plus 12y minus -36. This means -32 equal to 5y plus 12y plus 36. -32 equal to 17y plus 36. You now rearrange this. When you rearrange it, you have 17y plus 36 equal to negative 32. So 17y will be negative 32 minus 36. You move the constants to join the product. And then you now have that 17y is now negative 68. You divide both sides by 17, it gives you negative 4. That y is negative 4. So what's the next thing? You now substitute y equal to negative 4 into equation 3. And of course, equation 3 is x equal to negative 3y minus 9. So x will be negative 3 times negative 4 minus 9. So x will be 12 minus 9, and x will be 3. All right. We now check. That's the next thing, is to check to make sure that our equations are correct. So we have, for the first equation, this is negative 2x equal to 6y plus 18. Left hand side, right hand side. This is negative 2x. This is 6y plus 18. So we now have negative 2 times 3, which is negative 6. Here we have 6 times negative 4 plus 18. So which is negative 24 plus 18. And that gives you negative 6. So negative 6, negative 6. Our first equation is correct. We check for the second equation. Negative 32 equal to 5y minus 4x. This is negative 32. This is 5y minus 4x. We don't bother with this because this is already a constant. So this is 5 times negative 4 minus 4 times 3. So this is negative 20 minus 12, and that is negative 32. The same. That brings us to the end of question 5. Okay, question 6. We have equation 1 and equation 2. Of course, if you look at this question 6, you know the equation that we will start from. I mean, it's obvious that we will start with equation 2. So from equation 2, x plus y equal to 6, we have that x will be 6 minus y. Call it equation 3. Some people might say y equal to 6 minus x. It doesn't matter. Just make sure you do the right thing. You know how to move. When you're solving equations, when you view that video segment on equations, you know the principle of moving. Yeah. So you now substitute equation 3 into equation 1. Now we've used equation 2, so we substitute into equation 1, right? And that tells us that 5y will be equal to 7 into 6. Of course, if I write it, I know some of you might want me to write it again. 5y equal to 7x plus 30. We substitute for x. 7 into 6 minus y plus 30. That brings us 5y equal to, when you distribute, of course this is 7 times 6 minus 7 times y plus 30. 5y will be 42 minus 7y plus 30. You move, bring the like terms, right? So 5y plus 7y equal to 42 plus 30. So this is 12y equal to 72. And that gives us that y is equal to 6. Right? Y is equal to 6. So you now substitute 6 for y, or you can say substitute y equal to 6 into equation 3. So x is equal to 6 minus y, x is equal to 6 minus 6, and x will be equal to 0. So y is equal to 6, x is equal to 0. Then you check. When you check, you write the main equation. 5y equal to 7x plus 30, the first one. Left hand side, right hand side. This is 5y for left hand side. This is 7x plus 30 for right hand side. So here this is 5 times 6, which is 30. Here this is 7 times 0 plus 30. This is 0 plus 30, which is 30. 30 on the right, 30 on the left, we're good. Second equation, x plus y equal to 6. Left hand side is x plus y, right hand side is 6. Here is 0 plus 6, and this is 6. 6 on the left, 6 on the right, we're good. Question 6 is over. Thank you so much for this segment. There will be a part 2 segment. There will also be a segment for part 2 where I will solve more questions on using the substitution method. More questions, more complex ones as well, so that I want to solve all questions that you can expect. For a moment of conscience for this part 1, my heart is going out to all Christians that were killed on Christmas Day in Nigeria. You know, the world might not understand it, but the Christians in Nigeria, especially in the northern part of Nigeria, Christians in the north, they are suffering. We are suffering during these perilous times. I will call it perilous times. We are suffering greatly. I mean, Christians will be going about their business, and the next thing, there's a big trouble, and they kill people, they burn them on the streets, they burn people. They don't have any value for human life. So my heart is going to the families of all those who lost their loved ones on Christmas Day during the bombing. God in heaven is watching us, and He is with you. He is with us. God in heaven is taking note of all this. The world might be blind. The world might not be taking note of this, but God in heaven is seeing the suffering that we are undergoing. And God in heaven will rescue us. He's going to protect us. He's going to save us. Now, these people, innocent Christians, going about their business, going to church on Christmas Day, and then there's bombing and people died. I mean, but God in heaven is watching. God in heaven is going to comfort you. My heart is going to you in solidarity, in sorrow at this time. So please take heart, and please don't lose your faith in God. God is watching, and God will rescue us as we enter this new year. Thank you so much, all viewers, and please pray for these Christians who love their loved ones on Christmas Day. Thank you, and have a nice day. Bye.